Hello everyone, welcome to my programming club. Today we will be solving the problems of weekly contest 365. Now let's try to solve the problems of weekly contest 365. So the first problem of the contest, you are given a zero indexed integer array nums. Return the maximum value over all the triplets of indices I, j, k such that I is lesser than j is lesser than k. If all such triplets have a negative value, return 0. The value of a triplet of indices I, j, k is equal to the this following entity. Value of nums of I minus value of nums of j multiply value of nums of k. For example, here the triplet is considered to be the comprising of indices 0, 2 and 4. So the value calculated will be like this. So how we will be solving this particular problem is, let's have a look at the constraints first. So the length of array is of order 10 raised to power 2 and elements are of order 10 raised to power 6. So to solve this particular problem, we will be needing a triplet. So for a triplet, I, j and k indices are required in this fashion, and the value that is to be calculated is something like this. One thing I would like to mention is the second problem of the contest is exactly similar to this problem with a little difference of constraints. So we will be solving this particular first problem accordingly with these constraints so that we can kill two birds with one stone. We will be able to solve both of the problems if we solve this particular problem. So what we will do is, so the calculated value is like this. And in the constraints it's mentioned that all the values are positive. So if this particular evaluation is negative, then it will be negative because of this term. It will be negative basically when this nums of I is lesser than nums of j. So if we consider this particular index in all the set of the indices available 0, 1, 2, 3, 4, 5, 6, 7, so on. Let's say I consider j to be 3. Then I want maximum possible elements index, or say maximum possible element on right hand side, and I want maximum possible element on left hand side. Then we can easily get this will be your ith element, and this will be your kth element. So for 3 you will be getting maximum value. So we will try this with all the indices here that are present. For each index we will find the maximum possible element on the left and maximum possible element on the right hand side. So and we will do a single traversal of this array. For each of the index this value will be calculated. Each index will be considered j. And maximum possible value on left hand side and maximum possible value on right hand side will be calculated. Maximum possible value on left side and maximum possible value on right side will be calculated. Okay, these two calculations will be done for each index. Each index will be considered j for the calculation of this particular value. So for storing maximum possible value on right hand side we will use an array, and the name of the array will be max from right. For this particular part we will use an array max from right till a particular index. We will find what is the maximum value from right hand side till a particular index. Find maximum value from right hand side. Now once we get the values, maximum possible value from right hand side till a particular index, maximum possible value on left hand side will be calculated on the fly when we will be traversing this array, given array. Let's say we are at index I and dx, then the maximum possible value max left value will be calculated as we traverse this array, and it will be updated accordingly. So if at a particular case, let's say your current value at this index, let's call this current value. If this current value is lesser than max left value, then you will be having a triplet, valid triplet that will not give you negative result. Max on right hand side will be anyways available to you from that array, and you will do the calculation of value from this formula. Okay, now let's try to let's try to see the implementation, and there it will be more clear to you how we have implemented the code. this particular array will be used to store the maximum possible values from right hand side till a particular index. So for the last index, the maximum possible value from right hand side will be your nums value. There will be no value on its right hand side, no value on right hand side of last index. So after that, this ll is for long. I have used a macro. So from the second last index we will start traversing the array and we will store the maximum right till a particular index and keep updating this value. So it will either be maximum from right from one previous index will be carried on, or your new value of the nums will be the maximum right value. Then from maximum from right hand side will be stored in this particular variable, left hand side will be stored in this particular variable, and max from left will be updated as we move from left to right. Max from left will be updated as we move from left to right in the given array. And one thing is to be noted is we are skipping the last element in order to have a valid triplet. So if you do not skip the last element, you will be having only 2 elements. So to form the 3 elements always, there will be a case where you will be having only 2 elements. So to form always 3 elements, we are skipping the last one. So that's why size -1, less than size -1. And then if this is the case that your current value let me mention here that the index is, or say the index is considered to be a candidate of j in the I, j and ijk triplet, and I will be your max from left and j will be your max from right. It will be your j, it will be your k, sorry, k in the triplet. So if this is the case, then you will not get a negative value and you will update your maximum value and you will return that value. Let's try to submit it once. Same code will be working in the second problem also, since we are solving this particular problem in O of n space and O of n time complexity, where n is the size of the given array. Let's try this particular solution here also. As you can see, it's getting accepted here also. So both of these problems are being accepted. Solution for both of these problem is getting accepted. So let's move to the third problem of the contest. So the third problem is like this: you are given a zero indexed array nums and an target integer and an integer target. And a zero indexed infinite nums is generated by infinitely appending this nums array. For example, 1 2 3 can be infinitely appended. This particular array 1 2 3 1 2 3 1 2 3, it can be appended any number of times. Okay, infinitely many number of times. So you have to tell what is the length of the shortest subarray of infinite nums. This will be your infinite nums. Generated from the given nums array. This is the given nums array. So from in this infinite nums array, you have to tell what will be the length of minimum length of subarray whose sum is equal to target. So sum will be equal to the target. This will be given to you. Nums array will be given to you. These two things will be given to you. You have to tell the minimum length of the subarray whose sum is equal to the target. Those of you who do not know what a subarray is a contiguous part of a given array. For example, if the given array is like this, a subarray is a contiguous part. These two are valid subarrays, so there cannot be any deletions between this part. So this cannot be a subarray. 3,5 is not a subarray since 4 is missing here, so it is a contiguous part. So you have to tell its length. Let's have a look at the constraints. So length of the given nums array will be of order 10 raised to power 5, and the elements will be also ranging from 1 to 10 raised to power 5. Target is having a bigger value. It will be ranging from 1 to 10 raised to power 9. So this is the problem statement. We will be using hashing plus prefix sum to solve this particular problem. Prefix sum plus hashing. Those of you who are new to this concept of prefix sum, I will include a link to an article describing what prefix sum is. A link will be provided to you of an article. Anyhow, I will also try to explain it in my own terms. Consider this array 1 2 3 4. Let this be your nums array. And for this particular example, we are not considering it to be an infinite that infinite nums array to be generated. We are considering this array itself, and let the target be defined as 5. So you have to tell what is the minimum sum subarray, minimum length subarray whose sum of elements is equal to target. So as you can see, these two are summing to the target and the length is 2. So let's try to solve it programmatically. Let's mark the indices of the array. So what the prefix sum does is, for the first element, it will be 1. For the second element, it will be the value of the second element plus prefix sum of previous element, which will be 1 plus 2 will be 3, and so on. And then it will be 3 plus 3 6, and 6 plus 4 10. Okay, now what you will do is, for each of the prefix sum, let's say for this particular one, you will do 6 minus target, which is 5, and you will keep a map. Map will store the indices of the prefix sum. So your 1 prefix sum is occurring at the 0th index. This is the index, and this is the prefix sum. So it can be prefix sum index map. So on. Three prefix sum is occurring at the first index, and 6 prefix sum is occurring at the second index, and 10 prefix sum is occurring at the fourth index. So this is what the map will be storing, indices of the prefix sum. So what we will do is, we will see if this particular map is having this value as key, which is 1. So yeah, map is indeed having 1, which is having a value of 0, and we are currently at the second index. So what you will do is, the length of the subarray whose sum will be equal to the target will be nothing but current index, which is 2, minus index of this particular difference in the map, which is 0. So 2 minus 0 will be 2. So this is how prefix sum will help us to determine the length of the array, which will sum to a particular target. Okay. Some edge cases will be considered while solving this problem. Otherwise, this is the basic idea behind the problem. And let's say there is a if we add these 3 elements, they will sum up to 3 plus 2 plus 1 6, and let's say the target is given to be 12. So how many complete number of arrays you will be able to store, you will be able to use? So 2 complete arrays will be used. So let's call the number of complete arrays that to be used is k. So how you will find this k? You will find this k target divided by sum of nums array. It will be your k. So k complete sum arrays, some sub arrays will be used, and how many remaining will be used will be from determined from this value. Target will be now equal to its new value, which will be target modulo sum nums. So your operations will be applied on this particular value of the target. I hope you are able to understand. And then these operations will be applied of prefix sum. So let's see the implementation of the problem. Yeah, this is the implementation of the problem solution of prefix sum plus hashing. So what we will do is, first of all, we will calculate the sum of the array. To see how many complete nums array will be used. And then calculate, and then do the calculations for of remaining value of target given. So this will be the array sum, and this will be the current value of the prefix sum. This will be your size of given array. Number of complete arrays that will be used will be target divided by array sum. It's mathematics here. So, and then your result will be initially initialized to maximum integer value. You can initialize to anything you may like that is greater than or equal to the size of the array. Then what you will do is, your target will be updated to its new value. And in case your target is completely 0 now, it means that number of arrays that have been used till now will completely form the target. So you will just return this. In this case, complete nums used will be sufficient to form the given target. And you will return complete num used into size of single nums array. So this will be the size of the subarray, minimum size that is required. If that's not the case, then you will if that's not the case, then you will do calculations for remaining target that is not achieved with the complete nums array. So what you will do in this case is, let this be your nums array. You will append the nums array 2 times. Why 2 times? Because it will account for all the subarrays that will be taking some part of the previous nums array and some part of the other nums array. So 2 times appending nums array 2 times will be sufficient for this, and your range of indices will be varying from 0 to 2 into size of nums array, which is sz minus 1. I hope you are able to understand. So here nums array will be appended twice. To cover all the subarrays. Possible in this case. And your prefix sum value will be updated. Current value of prefix sum will be updated. Okay, and then if you have already seen this particular value prefix sum minus target, then there is a subarray. In this case there is a subarray that can sum up to target if the following condition satisfies. Following condition satisfies this condition. So length of the subarray that will be summing up to the target will be current index minus the index of this particular value. This is same to this logic that we have applied here. Here 2 was your current index and this was the entity that you were getting from subtracting the current prefix sum from and the target. So this one was present at the 0th index. So this will be your length of subarray. Length of subarray that sums up to target, or whose elements so you will update the value of the current prefix sum, value of the index of current prefix sum, update the value of index of current prefix sum. So this is how you will be solving the problem. So your result will be nothing but number of complete subarray used in 2 size, because these number of complete subarrays will be used which were of size sz, and rest will be your results value, which is this minimum value. So that's all for this particular problem. If you are still having any doubts, please feel free to ask them in the comment section. Now let's try to submit it once. As you can see, it's getting accepted. So let's move towards the last problem of the contest. This is the last problem of the contest. There is a directed graph consisting of n nodes. The problem's name is count the visited nodes in a directed graph. So there is a directed graph containing of n nodes numbered from 0 to n minus 1, and n directed edges are present. You are given a 0 indexed array edges where edges I indicates that there is an edge from node I to edge I. For example, if this particular edges array is being considered, and we mark the indices 0, 1, 2 and 3, and these will be, there will be a directed as from 0th index to the first indexed node. This is what the problem statement is saying. Indicates that there is an edge from node I to edge is I node, and the graph is a directed graph. So consider the following process on the graph. You start from any given node X and keep visiting other nodes through these edges. Let's say these edges are something like this. Okay, and this is your any node that you may like to pick. And this is being called X. Keep visiting other nodes until you reach the node that you have already visited. Now let's say your path that is formed via these edges is something like this. It's again ending at X or some other node that is already visited in this process. Let's say this node. Okay, then you will stop the process here. Since this node was already visited in this particular process, when this node was chosen your starting point, let me quickly change the color. Chosen starting point, any node can be your chosen starting point. So the process will stop as soon as a visited node is again seen. This was a visited node, you will stop here, your process will stop here. So you return an answer array, array named answer, which is the number of different nodes that you will visit if you perform the process at say ith node. So for example, let's say I perform the process at the first indexed node or the first node, then how many number of nodes will be visited for the process that will be done for this particular node considered as the starting point, chosen starting point. So we have to return an array in answer indicating those values, number of nodes visited. Different nodes or say unique nodes. Now let's see what the constraints are. So the length of the edges array will be of order 10 raised to power 5, and your indices or the edges will range from 0 to n-1, which is the length of the edges array. And it is mentioned that there will be no self loop, so there will not be a directed edge from a node to itself. So there will not be a something like this, will not be there for any of these indices. Okay, self loops will not be there. So these are the constraints. Now to solve this particular problem, what we will do is, since you have to return an array answer considering each index as your starting point of doing this particular process on your graph, that you start from a node X and keep visiting other nodes through the edges until you reach a node that have already been visited before or on this same process. So this process will not considered for a particular node, for a whole graph we are considering. So what we will do is we will consider each of the nodes as the starting points, candidate starting points. Consider each of the nodes as candidate starting points, and then accordingly what you will do is you will use a stack. You will be pushing the nodes as you visit them. For example, if you start at this particular node, then its next node will be this node. Let's call this X and let's call this Y. Then X will be pushed in the stack, then Y will be pushed, and so on. You will continue. Now your stack will be having one entire say path till node is being visited again. Now it is to be noted that it is not necessary that for this particular one, let's say Z is visited for process considered separately for X as starting point. Z may have been visited on, let's say, X1, which was some other node which was considered starting point previously before X, and for that Z was visited, so it will consider to be visited for this particular node to considered as a starting point also. I hope it's you have understood it. Since the process is considered as a whole on the graph, not on a particular node itself, so it's mentioned here also that the process is on the graph, not on a starting point and then considering another starting point to be a fresh point for the start of the process. So the process will continue. So I hope you are able to understand. Then what we will do is, if let's say upon visiting some nodes, you form a cycle like this. Now this is a visited node. For now do not consider this node. Okay, then if you know that this node is visited earlier also, then you will immediately know that a cycle is formed. Basically it's mentioned here also that this process will stop only when same visited node is visited again. Visited node is visited again, which is seen before in this same process. So let's say a cycle is formed here, and let's consider the length of the cycle length. Then for all the nodes in this particular cycle, let's mark them 1 2 3 4 5. 1 2 3 4. So for all of these nodes, the length of the path, that values of the answer array will be same as the cycle length. So answer of Y will be cycle length. Similarly, answer of Z will be your cycle length. Also answer of your, let's say, 3 will be your cycle length, and for 4 also it will be your cycle length. Why? Because this is the length of the number of different nodes that you will be visiting. If you, let's say, start from this particular one, so how many number of different nodes you will be visiting? 1 2 and 3, and including it 4. So it is indeed your cycle length. So for each of these nodes, answer will be your cycle length. For any other nodes that is connected to this cycle, what will be the answer? The answer will be nothing but let's say this node is connected and this is not the part, this is not part of cycle, so it will be answer of x will be answer of edge is x, which is answer of the node which is having a directed edge from x to that node, which is here y. So answer of y plus 1, y plus 1 plus 1 is for this x, x is for counting x, so it will be nothing but cycle length plus 1 for x. So this is the logic to solve this particular problem. So now let's have a look at the implementation. This is the answer array that you will be returning. Okay, and this is the visited set to keep track of visited nodes, and each of the index will be considered as a starting point. Will be considered as the candidate starting point, starting node, or say starting node for the process on the graph. Okay, then this is the stack which will consider the path or till it's the path for the current starting point. The stack will contain the path for the current starting point. Path is nothing but the nodes being visited till you encountered a already visited node in the process. So the stack containing the path for the current starting point. Current starting point will be your index. Okay, it will be named your current source. Then you will be storing nodes one by one into the stack, forming the path for the current starting point and continuing till you find a already visited node while processing the graph. So if it's the case that it have been already processed by some other node being considered as a starting point, then also you will stop, and otherwise you will keep marking that those nodes visited and placing them into your stack. And the next node that is to be visited will be the node that is having directed edge from the current node to from the current node. So this is the next node to be visited in the path. Okay, then if it's the case that you have already you have seen a already visited node, then a cycle is formed indeed, and cycle length will be this particular value. It will be beginning of your node stack minus the iterator to the current position of your node that is already visited. So you will repeat this process for, you will store the answer for all of the nodes that are in the cycle equal to the cycle length. This part will be done here. For all the nodes in the cycle, their answer will be cycle length. I hope you are able to understand. Then for all nodes which are not part of cycle, then if there are nodes which are not part of cycle but connected to the cycle nodes via a directed edge, then we will calculate answer for them. These are the nodes for which the answer is being calculated, which are not part of cycle. So this X was not part of cycle. Okay, and which will be cycle length plus 1, and at last you will return your answer. So that's how we will solve this problem. Let's try to submit it once. As you can see, it's getting accepted. So this is how we will be solving the last problem of the contest. So if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So thank you for watching. Thanks.